my name is Wei Lun. I would like to present the introduction of our project. The technology selected by our group is SWOOP. Firstly, I would like to present a little bit intro about Semantic Web. Semantic Web is an extension of the web through standard by the World Wide Web Consortium. Resource Description Framework is a standard model for data interchange on the web. Now, I would like to explain some introduction of SWOOP, the intention of SWOOP for the web, and also the problem tried solved by SWOOP. SWOOP is an open source and web-based OWL ontology editor and browser. Its ontology stored as HTML model. It can import from languages such as CWL, XML, RDF, and text format and export to languages such as RDF, OL, and DAML. It can support the platforms such as Windows and Linux. In addition, the programming language which interfaces with SWOOP is Java programming language. For the intention of SWOOP for the web is it can provide a multiple ontology browsing and editing because it contains OWL validation and offer various OWL presentation syntax view. It also provides function of semantic search. It can take inspiration from the hyperlink based on search utility present in a programming IDE such as Ellipse. Besides that, it also is a multimedia markup extension. It can be directly plugged into third-party semantic annotation tools such as SWOOP by itself. The problem tried solved by SWOOP is in problem in multiple ontology. It can support multiple ontology easily because all design decision in SWOOP is keeping with OWL nature and specification. Therefore, SWOOP can allow SWOOP user to edit OWL entity in a multiple ontology. Besides that, SWOOP also can solve ontology debugging problem because it has a debug mode which can augmented with information obtained from listener. SWOOP is able to solve ontology refactoring problem. It has prelimination support to paste and display connected ontology independently. That's for me. Thank you.
Now I will talking about the history of SWOOP2. SWOOP full name is called Semantic Web Ontology Overview and Brochure. It is a simple, scalable, hypermedia inspired OWL ontology browser and editor written in Java. It was developed and released by the Mind Lab at the University of Maryland, USA in the year 2007 and is currently an open source project with contributors from all over the world.
Next, I will present basic component in SWOOP. SWOOP is based on the Model View Controller paradigm. The SWOOP model component store all ontology static information pertaining to the SWOOP and define key parameters used by the SWOOP UI object. In addition, a SWOOP model listener class is used to reflect change in the UI based on change in the SWOOP model. The control is handled through a plugin based system which load new renderer and listener dynamically. The advantage of the plugin framework is to ensure modularity of the code and encourage external developers to contribute to the SWOOP project easily. Lastly, the entire SWOOP code is written in Java, maintained in a subversion repository, and make use of numerous third-party libraries. Figure 1 shows the SWOOP architecture for the plugin base. Thank you.
In this section, we focus on important features of SWOOP. All the features mentioned in this paper are with the reference to the version 2.3 beta 4 release of SWOOP, which can be obtained from this website. So user can download the SWOOP from this website so they can use it to edit the ontology. The easier and most direct way to load an OWL ontology is by entering its physical URL in the address bar. This action not only puts in the requested ontology, but also loads any important ontology into SWOOP automatically. There are certain characteristics of OWL ontology which are present to the user when a new ontology is brought into SWOOP. The ontology renderer plugin in SWOOP accomplishes this and displays statistics such as the logical construct used in ontology model, which determine the OWL species level the ontology belongs to, the description logic expressivity of the ontology, which is a key factor in determining complexity of reasoning, the number of class properties individuals, and so on, and also the annotation on the ontology object itself. SWOOP allows users to build or edit the web ontology by creating or adding the classes, object properties, data properties, and individuals. So when user click on the Add Class button, users are able to create a new classes. So when user click on Add Properties button, they are able to add a new object property. Object property describe relationship between two individuals. So when user click on Add Individuals button, users are able to add a new OWL individual. So when click on Class Tree button, users are able to see the class that they already created. When click on Property Tree, they are able to see the property that they already created. And last but not least, the individual list show that the individuals that already created by the user. Next is the versioning system control of the ontology. On each change of the original document, we first have to apply change before they can be reflected on the ontology. Anytime when error were discovered, using this version control, we could roll back to the previous good state of the ontology. For starters, it is essential to provide a search feature to help users to find related ontological information. Having found such information, it then becomes critical to compare and analyze this information in order to determine which part, if any, are useful. Search in SWOOP essentially perform a lookup for entities such as class, properties, or individuals across single or multiple ontologies among those that have been loaded. The results are obtained as a set of hyperlinks in keeping with the hypermedia-based UI, allowing the user to browse the search result easily.
Hello everyone, my name is Heng Zhongjing, and I'm going to compare the SWOOP editor tools with existing ontology editor tools. The existing tools that we selected is called Prodigy. It is an open source tool for editing and managing terminologies and ontologies. It is also implemented in Java and runs on a broad range of software platforms such as Linux, Windows, Mac OS, and Unix. It is built by using a tier architecture, which means that it's divided into layers such as ontology storage layer, knowledge model layer, graphical user interface (GUI), an application programming interface API. It comes with desktop application and web application, which is the same thing. Next, we'll move on to the general description of the Prodigy versus SWOOP. Now, first, Prodigy is developed at SMI Stanford University, while SWOOP is developed at MND University of Maryland. As you can see, both of them are open source tools, and they have the same extensibility plugins, and they do not have backup management. The architecture of Prodigy is a standalone and a client server, while SWOOP is a web-based and a client server. Prodigy store ontologies in the databases, while SWOOP store ontologies as an HTML models. Okay, now next, we move on to the strengths and the drawbacks of Prodigy and SWOOP. Prodigy first strength is its extensibility. Prodigy has a plugin architecture that allows developers to extend Prodigy's core functionality in many ways without needing to modify the Prodigy source code. There are more than 90 plugins that can provide advanced capabilities to Prodigy. Now, its second strength is the customization of user interface. Prodigy allows the creation of customized user interface for specific projects by changing the layout configuration. So it means that users can customize the user interface according to their preference. And the next is the strength of SWOOP. SWOOP has a multiple ontology browsing and editing capabilities. SWOOP ontology browsing and editing are done in a single pane, which helps to maintain the context. The different rendering styles, formats, and icons are used to highlight key ontological information. And its next strength is the multimedia markup extension. SWOOP itself can directly plug into third-party semantic annotation tools, which makes use of its fluid hypermedia-based UI to support rich text, image, and video markup. Now let us move on to the drawbacks of Prodigy and SWOOP. The first drawback for Prodigy is that it requires a constant update of the terminologies. Because the terms that are used in the application may be retired in the future version of the terminologies. That's why a constant update is needed to keep up with the versions. And the next drawback is that the insufficient compact visualization. The compact visualization provided by Prodigy may not be sufficient in cases of very large terminologies. Last, the new users may experience a learning curve when learning how to create terminology-enabled application. The next is we move on to the SWOOP drawbacks. The first drawback is the ontology debugging problems. Finding the cause of errors has become an extremely hard task due to increasingly complicated description into ontologies. And the second drawback for SWOOP is the ontology versioning problems. That also requires a constant update because of the evolving OWL ontologies. The ontology versioning mechanism is essential to maintain accuracy and to ensure interoperability with any linked ontologies. Last but not least, the ontology refactoring problem. The problem of refactoring large, complex ontologies into smaller, more manageable units is a hard research problem. So now that concludes my comparison between SWOOP with Prodigy.